Hello everyone. Today we're going to be talking about some real-world graphs. So in other words, we're going to be interpreting and creating graphs based on a situation. Go ahead and get out the notes that I've either provided you in class or as a packet, or you printed them off. If you have any questions, please let me know, and remember, do not leave a private comment. Let's go ahead and get started. So today we're going to be talking about real-world graphs, and we're going to be both describing and drawing graphs. So with the first example, I've been given a graph, and I want to be able to describe what's happening. So if we read number 1, it says the graph shows the height of a roller coaster during a single ride, and we want to describe the roller coaster ride. And if you look over to the right, we have time as the x-axis and height as the y-axis. So that means that based on the position of wherever we're looking, that's how much time has gone by and how high off the ground the roller coaster is at that time. So if we look at this, we can see that the first section, in other words, this section right here, this looks like the roller coaster is just leaving the gate. The next section, where the line goes really steeply upward, that looks like it proceeds in a climb. Just like the Big Dipper, or let's see, the Beast at Kings Island, there's usually a big climb at first, and then what happens after a climb? Well, then a rapid descent. Okay, after that, so that covers this section and this section. We're now on this one. So that looks like the roller coaster is again going up a hill. The coaster is going up another hill. And then has a small descent. So that's this section. Proceeds for a little bit, then climbs again. So this is the proceeding, this is the climb. We have a little bit longer descent. Let's see. We have another hill, or another descent, and then we come to the exit, so the exit gate. And that's basically what we're going to be doing. You're going to be describing the actions that are taking place. Another thing that we could be doing, if you look at number 2, we're going to be sketching a graph. This doesn't have to be very accurate, but we do have to discuss what could actually be happening, and we have to understand in our head what's going on. So let's read number 2. In a single day, it snowed lightly during the morning, then heavily for the rest of the day. Graph time on the x-axis and total snowfall amount on the y-axis. So on the x-axis, we're going to have time, and on the y-axis, we're going to have snowfall. Okay? It snowed lightly during the morning, and then heavily for the rest of the day. So if we try to describe this, if it snows lightly, we're not going to have a lot of snowfall. So let's say it snowed about that long, and then it started snowing heavy. So let's increase the snowfall, and that's a pretty good representation. So in this section right here, we had very steady snowfall. And then for this section, it turned into a blizzard. Okay? So as long as we're able to discuss what this graph could actually mean, we're good. So let's look at number 3. We have that Mia bought a painting. The value of the painting dropped by 25% after 1 year. Then increased in value over the next 5 years, reaching a value that was twice what she had paid for it. Graph time on the x-axis and value on the y-axis. So, on the x-axis, we have time. On the y-axis, we have value. Okay? Now, this one we have to be a little bit more precise with, because we have, 25%, and it doubled after 5 years. So, let's start about in the middle of value, so it's a little bit easier to determine. So we'll say that the value of the painting started here. After 1 year, it decreased by 25%. So we're going to go until we're about halfway in between this point and this point. And then it said that it rose in value until it reached double the original price. So that means it kept rising in value until it got double, which is about here. Okay? So that would be the graph of the price of the painting during the time. Okay, let's try number 4. It says a basketball was dropped out of a window on the second floor of a school onto the concrete below. Each time the ball hit the ground, it bounced and reached a height that was half that of the previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis and distance from the ground on the y-axis. So time is x-axis and distance is y-axis. Okay? So, if we drop a basketball specifically, out of a 2-story building, obviously the distance from the ground is going to be very high. And it's going to fall to the ground. And then we have the condition that it bounced and reached a height that was half the previous bounce. So that means it's going to bounce up until it's about halfway, half the distance of whatever the last bounce was. It's going to fall back to the ground. It's going to bounce half the distance. It's going to fall back to the ground. Half distance, fall back to the ground. Half distance, fall back to the ground. So on until it settles at the ground and just rolls away. Okay? So we're able to describe the distance as time progresses. Okay? So let's move on to number 5. Number 5 says that Jace is speeding on a highway and gets stopped by a police officer. The officer gives him a ticket and he continues on the highway. Graph time on the x-axis and his speed on the y-axis. Alright, so this would be time. This is his speed. Okay, so with this one, we have to be a little bit more methodical, because what's happening is we have to remember that he's being stopped by a police officer. Okay? So, let's try this. Let's say he's speeding. The cop puts on his lights and pulls the guy over. So we slow all the way down to 0. The cop gives him a ticket. This should be at 0. And then the cop lets him go away, and by then he learns his lesson to go the speed limit. So he speeds back up to the speed limit and continues on his merry way. Okay? So this is the graph that we're most likely looking at. He's going at a constant, let's say 80 miles per hour. He slows down to 0 miles per hour. And then let's say the speed limit was 65. So if you look at this, he's going 80. He gets pulled over. He goes down to 0 miles per hour. The cops let him go. He slowly moves back up to 65. And he stays at 65 because hopefully he's learned his lesson. Alright? Let's look at number 6. Carlos is running back on his football team. He ran the same number of yards in each of the first 6 games of the season. After the 6th game, he did not play for the rest of the season due to an injury. Graph games on the x-axis and total yards of the season on the y-axis. So on the x-axis, we're going to have games. And on the y-axis, we have yards. Okay, so we had a constant value for the first 6 games. So somehow he was running exactly the same in all 6 games. So that means that we have a steady growth. So in game 1, game 2, game 3, game 4, game 5, and game 6, we had a constant growth. And then since he didn't play anymore, we had to level off because he would not be able to run any more yards. So we have growth and then a constant. So that would be our graph. Okay. Number 7, Alice drives the school bus. On her morning route, she stops at every block to let students on. Graph the time on x-axis and total distance on the y-axis. Okay, so this is time for x-axis and distance for the y-axis. Okay, so this person leaves her house or her bus garage and goes to her first stop. So obviously she's going to be traveling. She stops the bus and lets the first kid on. Then she continues to the next stop. Stops the bus, continues. Stops the bus, continues, stops the bus, continues, stop the bus. Okay? So anytime that there's a stop or anything, we have a flat line. That means that the distance did not increase at all, and we just basically stopped the growth completely. Anytime that she was moving from stop to stop, we had a distance to grow. And since she stopped at every block, each of these segments, these right here, should be about the same. You know, it's not exactly the same because of human error, but that's okay. So let's try number 8. With number 8, we have that Ray started his workout by running on the treadmill. His heart rate rapidly increased and remained high during his run. After the treadmill, he lifted weights. His heart rate increased and decreased during his time. Now, what we have to do is figure out what needs to go on the x-axis and what needs to go on the y-axis. Well, in general, if you have time, it will go on the y-axis. Not the y-axis, the x-axis. And then whatever we're measuring will go on the y-axis. So in this case, it will be heart rate. So we'll have heart rate on the y-axis. Okay. Whenever he started his workout, he was running on a treadmill, and his heart rate rapidly increased. So our heart rate doesn't really start at 0. We usually have a resting heart rate of like 80. So we can say that started here. He started running on the treadmill, and it remained high on his run. So basically, the more time that you exercise, the higher your heart rate will go. And then after he started lifting weights, and that let him cool down a little bit. But then, he had a burst of speed, and his heart rate increased again, and then it decreased again. And this kept going on until he reached his resting heart rate again. Okay, so that's how we're able to describe the graph. We have that the heart rate increased rapidly while he was running on the treadmill. He started to cool down once he started lifting weights, but you had a burst of energy where he went hard on a couple of rounds and his heart rate went back up and then back down, respectively. Okay, so let's talk about number 9. We have Carrie, Luke, and Mason receive the same allowance each month from their parents. Carrie spent a small amount of her money in the first half of the month, then spent the rest in the second half of the month. Luke steadily spent his money throughout the entire month. Mason rapidly spent his money in the first half of the month. And what we have to do is match each child's spending with the correct graph below. So what you have to be able to do is describe the action that's happening within the graph. So if we look at the first option, it looks like we have some pretty rapid spending. Mostly because we go from 0 all the way to the top of the graph really quickly, and that's about half of the graph. So I would say this most likely belongs to Mason, since Mason rapidly spent all of his money within the first half of the month. Okay? So we're done with Mason, so let's mark through him. Now we have, let's say, Luke. Okay? It says that Luke steadily spent his money. So the steadiest looking graph would be the one that has the straightest line and the straightest continuous line. And that would be the third one. So I can definitely say that this is Luke. So we're done with Luke. And that means that Carrie has to be the middle one. But let's make sure that we guessed with the first one right. So with Carrie, we said that she spent a small amount of money in the first half of the month. Notice that this line isn't very steep. So since it's not very steep, we know that she didn't really spend a lot of money. And then it looks like the second half of the month she spent the rest. And if you notice, from here to here, the graph becomes really steep. And that explains that she spent a lot of money. So I do believe that these three people are matched with the correct graphs. Okay? And that's it for the notes. Hopefully, you're able to kind of understand this to a point. What I need you to do is to complete the notes, or make sure that these notes are completed and upload a picture to Google Classroom. You do have a homework assignment with this. It looks like it is about 11 problems. You're going to have 6 problems that look like problems 2 through 8. You're going to have 4 problems that look like number 9. And then you're going to have 1 problem that looks like number 1. So if you have any questions during this, please let me know. And other than that, I'm done for today, so I hope you have a wonderful day. Goodbye.